See that? I could go next. Now the particular house we've done 1, we've done 2, we've done 3, 4 children. I think we have the one that they have 4 children. Yeah. If you're looking at 4 children now, 4 children, here is 4 children. You see, probability of x equal to 4. And that is what? That is going to be 4 children. This is 4 children. Is that not? That's going to be giving us, for 4 children, that will be 2 over 20 multiplied by how many now? Multiplied by 4. Did you see that? That a particular house have 5 children. That's x equal to 5. And if you do with this, that's going to be 5 children. That's about for a house to have 5 children. 5 children, that's here, is that not? And that's going to be giving you 5 on 20 multiplied by 1. I hope you're following with this figure as I'm arranging it. Okay, so I think we've done sorry, this should be 1 on 20. That should be 1 on 20 by 5. So for a particular house now to have 0 number of children, we have it here. For 0 number of children, that's there. That will be giving us 3, right, by 20 for 0 number of children. Is that 3 or 4? That's 4. That's 4 because this is it here. For 5, did we talk about 5? Yeah, that's 5 there. So that's going to be is that 3? That's we made a mistake on this last figure here. Please, I hope you can go back there. This is 4 times 0. That's 4 times 0. Okay, so that's 4 times 0. That's it there. 4 times 0. So in case you're watching the previous video, you can just correct the error for us there. So and that will give us this is 4 straight away. Okay, that makes some sense. I'm just going to have to erase this away and put 4 there. Okay, so now in that way you're going to be getting off with 4 and 20, right, multiplied by 0. There we have it. Okay, now the beauty of this that I want you to remove is that don't forget that 3 on 20 is probability of x, where x could be anything. That's probability of x. You get the idea? That's all probability of x. If you sum up this, right, if you do this, if you carry out this operation, the answer here, right, value 1, I'm going to call it value 1. I'm just going to say value 1, which you know is the what is your mean. It's also the same thing as this guy, which is the value 2, which is also the what now, the mean. So the two operations are giving me mean. That they are both mean, right? But the formula for writing my mean in this operation here is summation is the summation fx divided by summation f. But the portion of writing my mean here is simple in another way. That means that my mean in this place here, because 3 over 20 is probability of x, is that not? That means it is the summation of the p of x. So the p of x now is the frequency. Does this make some sense now? That's serving as the frequency now. Then multiply by what now? By x. I don't need to divide it now. So my p of x now, in this case now, my p of x, if you're thinking about it, the p of x is not just any x. That is summation of fx divided by summation of f. And if you do this very well, that is equivalent to summation f multiplied by x divided by summation f. So this here is the p of x. I hope this is making some sense right now. We could think of summation being out of summation anyway. So that's our p of x. The frequency divided by the total summation. That's our p of x. So our p of x is not just any x, right? I can think of that as not saying the summation of f there, because you might want to make some error there to think of it as summation f. That's like this guys here, and now I'll take the giant summation. So if I do this, it's still the same thing. That's still the same thing. So this, right, is then referred to as e of x, which is called the weighted mean. The weighted mean or the expected value, right? And this can also be written in the other way as mu. So you might want to think of this is another way of writing your mean, your by x, all on a long run. That is what this concept is all about.